Hello everyone, welcome to Brain Blitz Audios. SATs are exams that students all over the world take to be qualified to go to colleges for admissions. So today we're going to be looking at some SAT questions under the new series, SAT Studies. So today we're going to be looking at some questions of mathematics which were asked in previous years of SAT. Let's begin with our first question for mathematics. What is the area of a rectangle whose length is twice its width and whose perimeter is equal to that of a square whose area is 1? So, how do we solve this question? Well, first you have to draw a rectangle and a square like this, and we know that the length of the rectangle is twice its width. So now we will consider A as the width of the rectangle. So now that we know A is the width, the length of the rectangle will be equal to 2A. Well, first we've sorted that out. So the width is A, length is 2A. Next, in order to find the perimeter of this rectangle, it is said that the perimeter of that rectangle is equal to that of a square whose area is 1. So the area of the square equals 1. Well, how do we express the area of a square? The area of a square is the square of the length of its side. So s squared equals 1. That means s will be equal to under root of 1, which is still 1. So each side of this square measures 1 unit. And so now we know the length of the side of the square. Then we can understand and we can calculate the perimeter of that same square. So the perimeter of the square is 4 times s, which in this case is 4 times 1, which is equal to 4. So since the perimeter of the square is equal to the perimeter of the rectangle, we will write 2a plus a times 2, which is the formula for the length, for the perimeter of the rectangle, and that is equal to 4. We have studied that the perimeter of a rectangle can be represented as 2 times L plus B. So here L is 2A, B is A, the width. So 2 times 2A plus A can be written as 2 times 3A, and that is equal to 4. 6A equals 4. And therefore a equals 4 by 6, which is equal to 2 by 3. So this is the width of the rectangle. The length of that rectangle will be 2 times a, which is 2 times of 2 by 3, that is 4 by 3. We need to find the area of this rectangle. That is the main question here. So don't lose sight of that main question. So once we got the length and width, it's on to us to find the area of that rectangle. The area of a rectangle, the area of the rectangle here is L times B. So the length here is 4 by 3, and the width is 2 by 3. 4 times 2 is 8, divided by 3 times 3 is 3 squared, which is 9. So the area of the rectangle will be 8 divided by 9. So here you can see that in SAT exams, it's really important to draw a diagram, which is important as it can help us visualize the question. So over here we have drawn a rectangle and a square, and we have visualized that the perimeter of this square will be equal to the perimeter of this rectangle. And so we found the side length of the square, found its perimeter, equated it to the perimeter of the rectangle, and we found the sides of that rectangle and then we found finally the area of that rectangle, which is equal to 8 divided by 9. Now let's move on to another question. A box contains 10 brown marbles and 30 white ones. How many brown marbles must be added to the box so that 60% of the marbles will be brown? How do we solve this question? Well, it is a question based on percentages, but then for visualization, the best way to do that is to use a diagram. So let's say this is our open box, and let's divide it into 3 layers. The first layer contains 10 marbles, which are brown. The next layer contains 30 marbles, which are white. And the last layer will contain x, that is the variable number of marbles that we will add, which will again be brown. Now, if we were asked to find out the total number of marbles in this box, it'll be 10 plus 30, which is 40 plus x. So therefore, the total number of marbles will be 40 plus x. And since we have 2 layers of brown marbles, the total number of brown marbles will be 10 plus x in this current scenario. Now, when the number of brown marbles is 10 plus x, the question says that 60% of marbles will be brown. So 60% would mean 60 divided by 100. That is 6 by 10, which is 3 by 5. So if we were to take the ratio of brown marbles to the total number of marbles in the box, so that will be 10 plus x divided by 40 plus x, that will be equal to 3 divided by 5. So let's cross multiply. So 5 times 10 plus x will be equal to 3 times 40 plus x. So that means 50 plus 5x equals 120 plus 3x. So 5x minus 3x is on the left, and 120 minus 50 is on the right. So we have 2x as equal to 70. So if 2x equals 70, then x equals 70 divided by 2. So the value of x is 35. So we will have 35 brown marbles added to the box in order to make the ratio, in order to make the percentage of brown marbles in that box 60%. Let's move on to another question. This question has options to choose from. Jake drove 8 miles west, 6 miles north, 3 miles east, and 6 more miles north. How far was Jake from his starting place? Well, in this kind of question, it's extremely important to draw out the diagram of Jake's travel. The reason being, in order to find out the direction from that Jake is from his starting point, or in order to find out the location of Jake's house from his current position. So let's say Jake started from a point A, and since the direction for west is along the left, let's draw a straight line, a straight line segment AB, which measures 8 miles, supposedly. Next, he goes 6 miles north. So therefore, in the upward direction, we're going to draw another line segment, BC, and the measurement of this line segment, BC, is 6 miles. Then he goes 3 miles east. So therefore, along the right, the line segment CD will measure 3 miles. will represent 3 miles. And then finally, the line segment DE, which is moving upwards, that is Jake's direction, will also be measuring 6 miles. So now we need to find out how far was Jake from his starting place. So Jake is currently at E, whereas he started from A. So a straight line connecting A and E would represent the distance traveled by Jake. Now, if we were to extend the line segment DE to a point which is on AB, then we will have made a triangle between A, the point on AB, which we can represent as G, as well as E. So let's draw that specific triangle here, and then we can start calculating distance. So we know that DCBG is a rectangle, and side BC is 6 miles, so therefore side GD also has to be equal to 6 miles. Similarly, side CD equals 3 miles, so the side BG has to be also equal to 3 miles. We know that the distance of AB will be the sum of distance BG and AG, so the distance AG is AB minus BG, so that's 8 minus 3, which is 5 miles. So side AG measures 5 miles, and since the distance GE can be written as the sum of GD and DE, which is 6 and 6, the total distance between G and point E will be 12 miles. So now we know our distances. Now we know the height of the triangle and the base of the triangle. It's time to find out the hypotenuse. So we have drawn a diagram such that it is a right-angled triangle. So we know that after all of his travels, Jake has reached a point northwest from his starting point, but now we need to find out the distance the displacement that Jake has traveled in order to get our answer. So we are going to use the Pythagoras Theorem. So according to the Pythagoras Theorem, AE squared will be equal to AG squared plus GE squared. So AG squared will be 5 squared, and GE squared will be 12 squared. So 5 squared is 25, 12 squared is 144. So 144 plus 2, 5. 4 5s are 9, 4 2s are 6, 4 plus 2 is 6, and then you have a 1. So you can do that easily on paper or on calculator, which is allowed in SAT. And you'll get the value of AE squared as 169. You just have to do a square root, but then I've memorized 169 as 13 squared, so therefore the value of AE will be equal to 13. So the distance traveled, the displacement traveled by Jake from A to E will be option A, 13. So he traveled 13 miles from A to E by using this circuitous route. So 13 is the correct answer, which is option A. Now let's look at the final question of this episode. By how many degrees does the angle formed by the hour hand and the minute hand of a clock increase from 127 to 128? Now, it doesn't matter whether it's AM or PM. We're using the 12-hour clock. So even if it's AM or PM, the angle will still be the same. All right. So we know that in a clock, the hour hand and the minute hand both travel 360 degrees. And that stays the same even if you're using a clock which is shaped like a circle or an oval or a square. The hour hand and minute hand follow a circuitous route. So the difference between the rotation of the hour hand and the minute hand lies in the time taken. The hour hand rotates 360 degrees in 12 hours. And 12 hours is the same thing as 12 times 60 minutes. So therefore, the angle displaced by the hour hand in 1 minute will be equal to 360 divided by 12 times 60. So 0 gets cancelled with the 0 here. 6 goes into 36 6 times. So therefore, you'll get 6 divided by 12. 6 goes into 12 twice. So therefore, that's 1 by 2, which is equal to 0.5 degrees. So the angle displaced by the hour hand for every single minute is half a degree. Now, the minute hand also rotates 360 degrees, but it does so in 60 minutes. So the rotation of the minute hand per minute will be equal to 360 degrees divided by 60 degrees. Divided by 60 minutes, so that will be equal to 6 degrees per minute. And here it's 0.5 degrees per minute. Now, we are finding out the increase of the angle between the hour and the minute hand between 127 and 128. So the time difference here is 1 minute. So within that 1 minute, the angle formed by the hour hand and the minute hand changes. So in order to find that change, the change in angle can be calculated as angle displaced by the minute hand in 1 minute minus the angle displaced by the hour hand. So that over here, so let's write it down again. So angle displaced by the minute hand in 1 minute minus the angle displaced by the hour hand in 1 minute. So we now know both of those values, which is 6 degrees minus 0.5 degrees. So the change in angle between the hour and minute hands between the time period, so in 1 minute, which is from 127 to 128, so that is equal to 5.5 degrees. So therefore, the correct answer to how many degrees does the angle formed by hour hand and minute hand of a clock increase from 127 to 128, the answer here will be 5.5 degrees. The reason being, in every minute, the minute hand turns by 6 degrees, while the hour hand also turns by 0.5 degrees. So since both hands turn, there is a net difference of 5.5 degrees so there is a net increase of 5.5 degrees in the angle between the hour and the minute hand for every minute. So therefore 5.5 degrees is the correct answer for this question. So that concludes this episode of SAT Studies. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We have a lot of tips and tricks regarding how to improve your memory and also various lectures. So you can always get our latest updates by hitting the notifications button below the video. If you want to share your opinion regarding what we've just did or regarding our other content, don't forget to post them in the comments section down below. So until the next webisode, take care, stay safe, and I'll see you next time. Bye-bye for now.